Good evening, everyone. Welcome to India's largest e-learning platform, Gradeup, and welcome to the session 25 most important topics for GATE CS 2021. Join the session quickly and mark your presence. I am waiting for you all. Today, we will discuss the most important topic in the GATE CS 2021 of operating systems, that is page tables. Join the session quickly. Lokesh, good evening. All the others, please do join and quickly share it to all your friends. Ask them to join live. How are you, Lokesh? लोकेश इसरो नोटिफिकेशन के बारे में अभी मैं कुछ नहीं बोल सकता हूं क्योंकि वो सिंपल आसान का जॉब नहीं है. I cannot give some fluke comment on it. Currently I cannot tell anything, but probably we can expect the notification in upcoming 2 months. That is my prediction. For a while, we will discuss page tables. Alright? Before I start, let me introduce myself quickly. I am Satyanarayana Kaitepalli with all the other credentials, and I teach computer organization and architecture, computer networks, operating systems, data structures, and algorithms. These are the classes which I am teaching in this month. 10 a.m. I teach computer organization and architecture concepts on Gradeup app. At 5 p.m. I teach algorithms on the app. 7:15, which is the current class, me and all our faculty together, we are teaching 25 important topics on YouTube. So try to join the sessions. If you are unable to join live class, at least try to watch the recorded one. Okay? So to start with, page tables concept. Everybody join the session quickly. Fine. We know that any memory will be partitioned. Any memory will be partitioned for effective management purpose. Right? So whenever we say this memory partitioning, two options arises. How to partition this memory? We may partition this into equal size partitions or fixed size partitions, unequal size or variable size partitions. Whenever we do fixed size partitioning, there may be wastage of space inside the partition. This is what we call as internal fragmentation. And in the variable size partitioning, there may be wastage of space outside all the partitions. This is what we call as external fragmentation. Why we are facing these issues? Because we are storing the process as atomic unit. Means we are storing all the process in the contiguous locations. Process we are storing in the contiguous locations. That's why we are actually facing this issue. So, what is the remedy or solution for this? A process is also partitioned, like memory is partitioned. A process is also partitioned. These are logical partitions into equal size. They are called, and such partitions are what we call as pages. Now, these pages are stored in main memory, which is partitioned into frames in non-contiguous locations. So we are storing the process partitions, which are pages, into main memory partitions. So this is what we say pages to frames mapping. As they are stored on a non-contiguous location, it is required to maintain or remember or store which page is stored in which frame number, or which frame, which page is stored in which frame. This database of page and frame mapping is called page table. Page table. For example, let a process is divided into eight pages. Main memory is divided into 64 frames. Assume. Let's say this is the process P0. 1, 2, 3, 4, 5, 6, 7 and 8. These are what we are calling as pages. Page 0 to page 7. These pages are stored in main memory This is main memory. Let's say this main memory is having 64 frames numbered from 0 to 63. Now these pages are stored on non-contiguous locations. Let's say page 0 in frame number 2, page 1 in frame number 3, page 2 in frame number 17, page 3 in frame number 18, page 4 in frame number 27, page 5 in frame number 43, page 6 in frame number 62, page 7 in frame number 63. So these pages are stored in non-contiguous locations. Now CPU may request any page, but where this page is stored in which frame, that has to be stored somewhere. That is what we are calling as page table. So in the page table, where this page 0 is stored in frame number 2, page 1 frame number 3, 2 frame number 17, 3 frame number 18, 4 frame number 27, 5 frame number 43. Like this, which page is stored in which frame number, that is maintained in a page table. So what is the essential content? So the essential content or the essential field in every page table is what? Main memory frame number. Now in a page table, will the page table be common for multiple processes, or every process has its own page table? Definitely every process maintain its own page table. Every process maintain its own page table. Now in the page table, the number of page table entries is equal to number of pages per process. Here it is not divided by, in one process how many pages are there. Every process will have the page table entries equal to number of pages. That means each page has its own entry. And now what is the essential field in every page table entry? Main memory frame number. Main memory frame number. Now other than main memory frame number, will there be any other fields in PTE, page table entry? Yes. The page table entry may have multiple other fields, like frame number is mandatory. In addition to this, there may be one bit called valid bit. It says whether this page exists in main memory or not. And there may be field called modified or dirty bit. This says whether the page is modified by CPU or not. because upon replacement this dirty bit helps. Similarly, we may have field called replacement bit, and there may be field called protection bit. Generally, these protection bits will be 3 bits: read, write, and execute. So if we want to restrict some page from writing, we may use these bits. So this is what generally a page table entry will have. Okay. Now observe, we are dividing a process into pages. Let's say this is the process P0, divided into 8 pages: page 0, page 1, so on to page 7. These pages are stored in non-contiguous locations of main memory. Let's say page frame 0, frame 1 is for operating system. Just I am assuming. So in the further pages, further frames, these pages are mapped, stored. Which page stored in which frame number? We are maintaining the page table. Fine. So this is the page table. Okay, everything is clear. Let's say 0 is stored in frame number 3, 1 is stored in frame number 5, 2 is stored in frame number 7, 3 is stored in frame number 9, 4 is stored in frame number 12, 5 is stored in frame number 14, 6 is stored in frame number 17, and page 7 is stored in frame number 50. Non-contiguous locations. Okay. Now the question is, where this page table is stored in, that is also stored in main memory. Page table also should be stored in main memory. Let's say the page table is stored here. So P0 page table stored here. Let's say this frame number is let us suppose 6. So who maintain the information of location of page table? That is what we call as page table base register. So this page table base register will maintain the location of page table, that is frame 6. Okay. Now whenever CPU generate the address, when CPU generates, what address CPU want, what CPU request? One word at a time. So the CPU generates word address. This word address is interpreted as, this address is understood or interpreted as page number in that page which word we are requiring. CPU will not give page number and offset. CPU just give the consolidated word number. For example, let a page is having 4 words. One page is having 4 words. Total 8 pages. That means total 32 words in a page. 32 words means 2 power 5 words. So there will be 5-bit address for every word. Suppose CPU want word number 23. Let us assume CPU want word number 23. Rituraj, I have seen your message. Just wait, I will address you. I will answer. So word number 23 is converted into binary and represented in 5-bit form. Why 5-bit? Because there are total 32 words. So this would be right. This is in binary 23. Binary form is this. Now in one page, how many words are there? 4 words. 4 words means 2 square. That is 2 bits. In one page to represent every word. Like if this is the page, let's say this is the page, word 0, word 1, word 2, word 3. So this will have 0, 0, 0, 1, 1, 0, 1, 1. Like this. So 1, 0, 1, 1, 1, whenever CPU generate, immediately this is divided into word offset. 2 bits for word offset, remaining 3 bits for page number. So it indicates CPU want word number 3 in page number 5. In page number 5, word number 3, CPU is requesting. That is what the meaning. That is how it is understood. But where these pages are stored in, but we know all the pages are stored in main memory frames. So page number, word offset, whatever the CPU generated address we are interpreting as, this is what we are calling as virtual address. This virtual address should be mapped to or translated to physical address. The virtual address should be translated to physical address. What is physical address? For that page number, what is the corresponding frame number? That is what stored in physical address. And the offset remains same. So if we are having page number with word offset, this is verified in the page table. In the entire page table, for page number, frame number, this is verified, and corresponding frame number word offset. This translation happens. So here what we can understand, how many words in one page, same number of words in one frame. That means page size must be equal to frame size. This is very important point we have to understand. Ritu Raj, you are just 12th pass student. Once you join your engineering, you can start your preparation with mathematics. Once you come to your second year, let's half of the second year over. Meanwhile, you prepare your mathematics thoroughly, and C programming also you can prepare for. Both are in GATE CSE syllabus. Then automatically you will understand what to prepare, what subjects are in the GATE. Okay, you can start your preparation with mathematics, aptitude, C programming for as of now. Okay, Rituraj? Right. Now we know process divided into pages. Pages are stored in non-contiguous locations. Those frame numbers are stored in page table. Page table is stored in page table main memory frame that is maintained in page table base register. All this concept now we have understood. If page table size is greater than frame size, if the page table size is greater than frame size, then page table cannot fit in one frame. Then multi-level paging. Is needed. What is multi-level paging? I will explain with one simple example. Nitesh Kalla Nitesh, on our Gradeup app for mathematics, always classes happens in the Gradeup app. And if you are from CSE, always we will be doing one or the other course, other series for programming or data structures we will be doing. So you can just search in our Gradeup app. So download our Gradeup app and select GATE CSE or whatever the branch you are from. Then automatically and register with your mobile. Then automatically you will get notifications about all our free series. But as I remember, I can say mathematics classes will happen. You can attend them. Rituraj, even you also. Alright. Now, what is this multi-level paging? This is the main memory. Divided into frames. This is the process divided into 8 pages. Every page has its own frame number. Let's say page 0 from 3, 5, 7, 9, 10, 12, 14, 15. This is the page table, okay? Let page table size is let's say 64 kilobytes. Frame size is 8 kilobytes. Page size or frame size will be same, guys. Remember, I am not telling page size is 64 kilobyte. Page table size is 64 kilobyte. Page size is 8 kilobyte. Means than the actual data, its metadata is taking more memory. Now, obviously, this page table you cannot fit in one frame. So now what we do? So divide this page table into pages. Process divided into pages. Now we are dividing page table into pages. How many pages? How many? So 64 by 8. So 8 pages. So I am dividing this page table into pages. See here. This is one page. Let's say this is page table A. So this is the page, first page, A0 of page table A. This is A1, page A1. This is okay, 8 pages, right? A1, A2. Just a moment. Just let me change the values. So let it be 16 KB. So we will be dividing this into 4 pages. Just for better understanding, I am changing it. So let it be page A0, page A1, page A2, page A3. Now these pages A0, A1, A2, A3 are stored because their size is equal to frame size, right? Now where these A0, A1, A2, A3 are stored, that also should be maintained. So that we are maintaining another page table. Let it be page table B. So in the page table B, A0, let's say this is maintained in 10, 11. Okay, wait. 13, 15, 17, 20. Because 10 is 10 is occupying page, no? Now this A0 is stored in frame 13, A1 is stored in frame 15, A2 in frame 17, A3 in frame 20. So with 8 entries, the size is 64. With 4 entries, let this size is 32 KB. But 32 KB also exceed page table size, right? So now divide this page table B into pages. How many? One page size I am taking as 16 KB. So into 2 pages. So process divided into pages, its information maintained in one page table, that is divided into pages, that information maintained in another page table, that is again divided into pages. So let's say this is page B0, this is page B1. B0 is stored, let's say, in 6. B1 is stored in 8, page number 8. So this information is also maintained in one page table. This is page table C. Now this is, its size is 16 KB, so which fit. So let's say this is page table C, 63. So 63 is maintained in page table base register. So this is level 1 page table, level 2 page table, level 3 page table. This is level 3 page table. This is what multi-level paging concept. Okay. Alright. Now, once CPU generates virtual address, it should be mapped to physical address. It should be mapped to physical address. For conversion of this, what we use? Using page table. So, if we take one level or single level page table, single level paging, CPU generates virtual address. Now, what CPU access? So CPU, or you can say operating system access page table base register, which will be in process control block. Now, in this page table base register, where page table is there, that will be there. Now, access or read main memory for page table. Read the main memory for page table. Now, in the page table, our corresponding page is stored in which frame will be there. So, map page number to frame number. Map page number to frame number. Now again, read main memory for page. Now you know in which frame you have. Read the page from that main memory. So this is what the process for one virtual address. So in this process, the number of times main memory is accessed, the number of times main memory is accessed is equal to 2 times. Why? One for the page table, this is 1 time, one for the page, right? So now, if we take multi-level page table, there are X levels. X levels of paging we are doing. Then we will access x times main memory for page tables one time for the page. So total main memory accesses will be always x plus 1, where x is number of levels of page. But we know main memory is slow. But main memory is slow compared with CPU. So what we do? Frequently accessed pages information we are maintaining in a faster memory called cache memory. Is maintained in faster memory called cache memory. This cache memory known as translation look aside buffer. TLB. So before we read main memory, first we verify whether the required page is in TLB or not. So if required page information in TLB, we call that is TLB hit. Otherwise, we call this as TLB miss. Okay. Now, if a CPU generates if the CPU is generating multiple requests, then what is effective memory access time? What is effective memory access time? Let TLB hit ratio is equal to H. TLB access time is T1. Main memory access time is T2. Then what is effective memory access time? How many hits are there? All. We will access one time TLB, one time main memory. Why main memory? TLB you will get frame number. Directly you will be accessing the page. If that page information is in TLB. If that page information is not in TLB, means if it is a TLB miss, then as usual, you will first verify TLB, whether the page information is there in TLB or not. That require T1 time. If it is miss with TLB, then we will verify, as usual, we will access main memory twice. For single level page table I am taking. For one level page table, this is the case. If you are taking X levels of page tables, then that is T1 plus how many times of T2? On hit only one time. On hit only one time. On miss, this would be X plus 1 into T2. Because X times you will be referring main memory for the page tables. last time you will access the page. Okay, so this is how we will calculate effective memory access time, considering there is no page fault in main memory. There is no page fault in main memory. This is the effective memory access time for single level page table for X levels of page table. What is page fault? When page fault occurs? What is demand paging? With page fault, what is effective memory access time? This is all again another story that we will discuss, like you may get it later. But as of now, that's all for today. This is what complete page table concept. So let me introduce our innovative courses, Gear Up, Rank Up, Vision 2022. If you are aiming for 2022 gate, Vision classes are suitable for you. Rank Up is for more practice. Gear Up is to build your concept. To attend all these courses and any course that happen for PSUs like ISRO, BARC, NEELIT, DRDO and any other, take Gradeup Super subscription. One subscription you can access all the courses. And we are the faculty who teach all these courses, Mr. Murali sir, me, Ankit sir and Navneet sir with the relevant experience you can see. And these are the 2020 Gradeup Achievers, All India rank 4th, 39th rank holder, 47th rank holder in CS, used our Gradeup test series. Our Gradeup test series helped them in getting this AIR, guys. Sagar, I think Murali Krishna sir will be teaching this TOC in 2022. I think, but I am not sure. You can check it in the study plan, Sagar. Okay. So take Gradeup Super subscription and access all the structured live courses taught by best faculty. Get all your doubts resolved, and you will get access to green card with super subscription, through which you can access all the online mock tests designed by toppers as per the latest exam pattern. So why late? Take Gradeup Super subscription. 3 months, 12 months, 18 months and 24 months fee details are here. So you take more period, you can access more courses and you will be paying less per month. If you have any doubts or queries, here is the contact number. You may contact, or you may mail on help@gradeup.co. Thank you. Thank you guys. Merry Christmas to all. All the very best. Prep smart, score better, go Gradeup. Thank you.